everyone. Thank you for joining our webinar today. I'm Charlotte from ICP Desk International Marketing Department. Today, I'm going to talk about build a cloud-based energy management platform for low-carbon smart manufacturing. I will share about some case studies and solutions provided by ICP Desk. So now let's get started. First, I would like to ask you one question. If you want to save energy, what should you do first? Use energy efficient lighting or turn the AC on at a higher temperature? Let me ask you in another way. When you want to lose weight, what should you do first? You should weigh yourself first. You need to set on a scale to weigh yourself first to know your weight, so that you can set up a goal, a weight loss plan, and to evaluate the result. Likewise, when getting started on energy saving, what should go first? Measurement should go first. Collecting and monitoring the data can help you understand the status of energy consumption and set up an efficient plan to achieve energy saving. Data acquisition and monitoring is ICP Desk's strength. In ICP Desk, we have many different sensors to collect the different data, which can help the customers to do the data recording, such as voltage, current, temperature, humidity, CO2, PM2.5, liquid leak, power consumption, etc. And now, let me introduce some energy management solutions which ICP Desk provided to our customer, how we use our cloud-based energy management platform to help our customers achieve remote monitoring. First case study is about water supply monitoring system in India. In order to solve the problem of uneven distribution of water resources and achieve their efficient use, in recent years, the government of India has committed itself to the management of water resources. The traditional water resource monitoring method was to install a PLC at each water supply system to collect information obtained by sensors about water flow, water pressure, and water level. However, because the equipment was located in places remote from each other, it was difficult to get the real-time data and control the water supply system centrally. Therefore, the customer decided to use IoT cloud method to transfer the collected data to the monitoring center and remotely monitor the status of 250 devices in real time via 4G while maintaining the original structure. So we use ICP Desk's WISE5231 and 4GE edge controller to send the data collected by PLC to IoTstar cloud management software, which is installed in the control center via 4G wirelessly communication. In this case, the customer uses the IoTstar to collect the equipment status data from sensors which are connected to WISE controllers, then store the data in the database and display it on the dashboard. The management personnel can monitor the real-time status of the water supply systems in the field remotely and achieve the goal of preventive maintenance. Second case study is about solar power plant monitoring in Thailand. The government of Thailand has already installed 150 solar power plants in Phuket and its surrounding 32 outlying islands in the southern region to collect data on power generation and equipment status. The customer wants to use IoT technology to transmit data from each solar power plant on each remote island via 4G to the control center in Phuket. We provide a cloud data visualization solution to our customer, which uses WISE5231 and 4GE combined with IoTstar. In this case, the customer uses IoTstar to receive the solar power plant data sent from the WISE, then import it into the database and display it on the dashboard. This solution allows the customer to monitor the status of the equipment on a remote island at the same time, which can achieve the goal of remote monitoring and reduce the time and the cost of sending personnel to the field. Third case study is about the wind turbine foundation monitoring system in the UK. The customer is one of the leading specialist asset maintenance contractors for buildings and structures operating across the UK, primarily providing comprehensive asset refurbishment, repair, and regular maintenance services. Due to the large weight of the wind turbine, the soil underlet becomes loose, which leads to the distortion of the turbine foundation. When the distortion of the foundation increases, it can lead to an unplanned shutdown of the wind turbine, further affecting the overall operation efficiency and increasing the maintenance cost. In the past, the client had to send someone from the staff to the field to record wind turbine vibration data. However, it took too much time and effort. Therefore, the customer decided to use IoT technology to wirelessly transmit machine vibration data to a monitoring center in London. Therefore, we provide our customer a cloud data visualization solution. On the wind turbine field terminal side, the WISE 5231 and 4GE transmits the collected data to the control center via 4G. The control center then can implement preventive maintenance by analyzing vibration data to prevent wind turbine failure in the future, thereby reducing maintenance costs. Through the case studies, we can tell that recently, more and more customers are interested in remote monitoring and IoT cloud. And there are many IoT sensors and related solutions on the market. So what is the difference between ICP DAS and other companies? And what is the strength of ICP DAS? Nowadays, most of the IoT cloud structures on the market are traditional two-tier structures. However, the disadvantage of a two-tier structure is that a large amount of data will be sent to the cloud at the same time and implement the data analyzing and logic operation on the cloud. It will not only consume a lot of network traffic, but also increase heavy loading to the cloud and cause slow responses outside. If the network is disconnected, the entire system outside will even be shut down directly. So to avoid this problem, ICP DAS provides a three-tier structure of IoT cloud, including edge computing layer to improve the lack of the traditional two-tier IoT cloud structure. The edge computing layer can be responsible for the logic control in the field. Except for reducing the loading to the cloud can also get faster responses in the field. It can also avoid system shutdown caused by internet disconnection and reduce data transfer costs. ICP DAS provides two series of edge controllers, WISE and the PNC. The following, I will introduce the features of our two edge controllers. About the features of ICP DAS's WISE series edge controllers, first is easy to use. The WISE series products have a built-in web interface, which allows users to log into the module through a web browser and to easily set up configurations without additional software or programming skills. If-then-else logic rules. The built-in if-then-else statement adopts an intuitive and logical approach of human. This part, I will explain more details later. Support various sensors in I/O modules. The WISE series products support ICP DAS expansion board, remote I/O modules, and Modbus protocol, which can easily meet various requirements in different applications. Support 4G mobile network. The WISE series products support 4G wireless communication, which can solve the problem of wiring. Data logger. The built-in data logger of the WISE series provides the data recovery function. When a network failure occurs, the collected data will be stored in a micro SD card and resent to the control center after resuming from network outage. Support real-time alarm notification. The WISE series products support email, SMS, Line, and WeChat sending notifications. In the event of an error, the alarm notification will be sent to management personnel immediately. Support various IoT communication protocols. The WISE series products support various IoT communication protocols, including MQTT, Modbus TCP, Modbus RTU, SNMP, and FTP protocols, and support commonly used IoT cloud platforms. The WISE series products support the Microsoft Azure and the IBM Bluemix cloud platforms, and it also has the Microsoft Azure certification. Now let's back to if-then-else. If-then-else is an important and useful function of WISE. With WISE, no programming is required, nor a development environment. All you need is a mouse to click the settings and to edit the control logic. So what is if-then-else? Before we talk about if-then-else, first you can think about one question. What to do next when things happen? This is a way of thinking when humans encounter problems. When you feel thirsty, you drink the water. And when you feel hot, you turn on a fan. It's the same logic for if-then-else. Now let's see some examples. When someone opens the door, the light will turn on. Now, I will show you how to set up the control logic. What we see now is the WISE building web. First, we need to set up a condition at if. Then click DI and set up the status of DI as on. Here we suppose the DI means open the door. And then we go back to the home page. Now we can see there is a condition. And now we are going to set up an action of then. And click DO. Then set up the status of DO as on. Here we suppose the DO means turn on the light. Then we back to the home page. And now we can see there is an action here. And now we are going to do the same thing for else. Here we set up an action and choose DO. However, here we set up the status of DO as off. And now we complete the control logic. When the DI is on, the DO will be on. Otherwise, the DO will be off. So when the door is open, the light will be turned on. So as you can see, we can complete a control logic without any programming and development environment. And here are all the parameters we can use for if condition and then else action. PMC series products are especially for the users who want to monitor the power information. PMC series products have the advantage of WISE and can integrate with ICP-DES single-phase and three-phase smart power meters and provide several functions such as statistics and analysis. ICP-DES also provides the PMD series, which have an additional touch panel for on-site power analysis and debugging. PMC series products provide real-time data recording of electrical equipment and the daily power consumption statistics, which can be used to manage production efficiency. The supervisory unit can understand the power consumption status of the machine from the reports. And PMC series products also provide the demand forecasting function. It will first analyze the power consumption in the past period and calculate the predictive power consumption in 15 minutes. This function is very useful for the users who have signed the contract capacity. For example, when PMC finds that the demand forecasting will be higher than the contract capacity in 15 minutes, it will send the alarm notification to the management personnel and uninstall some unnecessary devices automatically to reduce the overall power consumption, which can avoid the excess demand penalty. On the other hand, when the demand forecasting is lower than contract capacity, it will switch on some equipment to increase production capacity. PMC series products also provide yearly, monthly, weekly, and daily reports. Users can view the reports on the browser or export it to Excel format. PMD series products are ICP-DES edge controllers for power management with a touch panel. PMD series products have the same functions of PMC, but with the touch panel, users can easily understand the real-time power consumption status and set up the system parameters in the field. Now let's talk about the cloud. Why do we still need the cloud after we have edge computing layer? Actually, the cloud and the edge computing layer can help each other. For example, there is a massive storage space on the cloud to store the data, which is beneficial for big data analytics. Cloud also has the features of high reliability and high scalability. Users have no need to worry about data loss due to hardware failure. In addition, the cloud can be accessed anytime and anywhere, as long as the internet is connected. Because of the increased need of the cloud, ICP-DES has launched IoTstar and provides an IoT cloud solution. And now I'm going to introduce what is IoTstar. IoTstar is the cloud management software. You can download IoTstar from our website and install it on a PC or a public or private cloud. You can also choose to install IoTstar on a cloud-based virtual machine such as Azure and AWS to reduce the cost of hardware and electricity and have no need to worry about failure of hardware. Once the installation is complete, you can have your own IoTstar server. Now, what you need to do is connect your IoTstar with the edge controller. And IoTstar supports WISE, PNC, and PND. IoTstar provides a web interface. Users can enter IoTstar simply via the web browser without installing any additional software. IoTstar has 5 major services: remote access service, sensor data service, dashboard service, report service, and bot service. Now I'm going to introduce the 5 services. First, remote access service. Maybe you have the experience like when you try to connect to a device which is in another local area network, or try to type the IP of a device which is connected to a mobile network, and you failed. This is because the IP address used by these devices is virtual IP, and the virtual IP cannot be accessed from the external network. So now there is a problem. How can we set up the configuration or monitor the data on the built-in web page of WISE or a PMC remotely? With IoTstar, you can solve this problem. With IoTstar's remote access service, users don't need to worry about the network environment of the WISE or PNC controller. whether the controller uses a static IP, dynamic IP, virtual IP, or a physical IP. With IoTstar, the management personnel can perform status monitoring and system settings remotely. In addition, IoTstar allows the users to update the firmware of edge controllers with a simple click. Users only need to go to IoTstar's web page and click Update. It can automatically download the corresponding model firmware of the remote controller and update. It's very helpful for the users who have several edge controllers. It can not only help the users save the time, but also ensure to update the right firmware. Sensor data service. IoTstar can collect the data from the sensors, which are connected to the edge controllers, and store it in the database. One of the strengths of IoTstar is that it supports data logger. When the network is disconnected, the collected data will be stored in the edge controller's micro SD card. And when the network is resumed, all the data will be sent to IoTstar and be imported into the database. And another special feature of this service is that users can also execute a SQL command to control the I/O modules for the database. For example, turn on the light. When IoTstar receives this SQL command, it will demand the controller to turn on the light. It allows IT personnel to use SQL commands to control I/O modules directly without learning industrial protocols such as Modbus protocol. It's time-saving and allows IT systems to integrate with OT quickly. Also, the database of IoTstar is open for access to third-party services. Users can develop their own websites and collect the data stored in the database, then display it on the dashboard. Users can also develop their own applications to control the device, which are connected with the controllers. In addition, IoTstar can also be integrated with some data visualization tools, such as Microsoft Power BI or Google Data Studio, or it can be integrated with SCADA or HMI. Those are all the benefits of using an open asset database. IoTstar supports several databases, including the top 3 most popular databases of today. They are Oracle, MySQL, and SQL Server. And the market share of the 3 databases is 62%. Such popularity allows IoTstar to easily import the collected data into the user's current database or integrate with their ERP or MES system. Dashboard service. IoTstar has a built-in data analysis interface, which can display the real-time data of different devices. There is also an energy and power data analysis interface, which allows the users to understand the power consumption status of their equipment. This data is very useful for the companies to evaluate the energy management, greenhouse gas emissions, and the carbon emissions. Users can also check the daily, weekly, monthly, quarterly, or annually data, or compare the data of different periods, for example, today and yesterday. The data can be displayed in the form of a round chart. For example, the green one is the power consumption of yesterday, and the red one is the power consumption of today. And you can see the power consumption and the carbon emission or growth rates on the right side. Besides the basic data analysis interface, IoTstar also provides dashboard service for advanced users. With the dashboard service, users can build a situation room with visualized data, which enables the management personnel to quickly understand the on-site situation. The dashboard service has built-in various widgets which allow users to design their own dashboard, such as pie charts, gorge, or bar charts, and the different widgets will continue to be added in the future. And each widget can be freely resized or relocated. In addition, the parameters of the widgets can also be adjusted. Let me show you some examples. For example, this is an example of indoor air quality monitoring. And our dashboard also provides night mode, which can reduce the eye fatigue. And this is an example of energy monitoring. And this one is environmental monitoring. And there is a special widget here. It's video event list widget. Video event list widget can display the event captured by the on-site iCam series IP cameras. In the event of an error, for example, the door is opened, the Y series controller will activate on-site iCam series IP cameras to capture real-time images and transmit them to IoTstar and display them on the dashboard. Report service. IoTstar's report service provides a statistical report for the parameters or the channel value of the I/O modules connected to the WISE, PMC, and PND. Users can edit reports on the web page. For example, here I can change the color of the title into red. The report can be exported to PDF or Excel file format. Last, bot service. This service allows users to check the real-time data anytime and anywhere for the live communication application. Users can not only receive the real-time image or video notification through line, but also can change the I/O module's output channel value. Our bot service provides rich menus instead of traditional chatbot and supports Android and iOS systems. Let me show you how to use this service. First, when we open the chat room in line, we will see the menu below. If we want to query the real-time data, we need to click the channel and the bot will show you the information. Here, we suppose AIO means concentration of CO2. So we can know that now the concentration of CO2 is 793 ppm. And if we think that the concentration of CO2 is too high, we can also turn the ventilation fan to improve the indoor air quality. What we need to do is click the DO channel, then the robot will ask what we want to change. And here we choose on, then the ventilation fan will be turned on. In addition, as the function we mentioned before, we can also receive the real-time image or video notification, which is captured by ICP-iCam series IP cameras in the event of an error. So let me summarize the features of IoTstar. No need to worry about the network environment of the controller. Users can access the configuration web page of controllers regardless of virtual IP or dynamic IP. Programming-free sensor data collection. With IoTstar, the historical and real-time data can be automatically imported into the database. In addition, IoTstar provides data recovery mechanisms. Therefore, the users have no need to worry about losing the data. Open database. The third-party software can access the database for data analysis and I/O channel control. Simple data display and analysis interface. Users can monitor the data directly through the browser. Personalized dashboard. Users can build a specific dashboard with various widgets available. Report function for sensor and power meter. Users can design a specific report which meets their needs and export them to PDF or Excel formats. And bot service. Users can query the real-time data, set channel values, and receive camera video events via the Line application. IoTstar has two versions, basic and professional. The basic version is free and has the same services with professional versions. The only difference is the number of the controllers supported. However, the dashboard service, report service, and bar service are optional, and we provide a 90 days free trial for users. In addition, we provide an IoTstar trial for users who already have a WISE or a PNC or a PMD controller. Users only need to apply on our website and will get an exclusive IoTstar account. This account offers a 90 days free trial. Users can experience the features of IoTstar immediately without any installation. And also it provides 1 GB database space to store sensor and power meter data. And it provides a full functionality, including dashboard service, report service, and the bot service. If you want to know more about the IoTstar trial, you can go to the website of WISE, PMC, or PND to get more information. And there is also the IoTstar live demo, which you can try on our website. And if you want to know more about ICP-DES industrial IoT cloud solution, you can go to our website to get more information. Thank you for your listening, and don't forget to scan the QR code and complete the questionnaire, and we will send you the PPT file after the webinar.
Okay, I welcome all attendees back to the ICP-DES web seminar. This presentation is about ICP-DES EtherCAT solution. Thank you for showing interest into our EtherCAT series and taking the time attending this meeting. My name is Martin Kroschert, and my department at ICP-DES is responsible for the development of ICP-DES EtherCAT series. This presentation will first give a short introduction to the EtherCAT protocol, its benefit and advantages in the automation industry. The main focus of this presentation is to give you an introduction into the ICP-DES protocol solution, and starting from the EtherCAT master and slave series, the diagnostic and configuration software, the application software programming tools, etc., needed to implement an EtherCAT-based motion control application. And at the end of the application, this seminar, a couple of EtherCAT motion control applications are shown, which are using our EtherCAT products. First, a quick introduction into the EtherCAT feature, its main key features, and why is it so appealing in the automation industry. What is EtherCAT? EtherCAT stands for Ethernet of Control Automation Technology. It is an industrial communication technology based on Ethernet designed to be used in the automation. EtherCAT is one of the fastest and most popular industrial Ethernet products, especially for the PC automation, and it has been growing at a fast rate. The main reason is that it addresses some specific concerns for the industrial automation, such as fast communication with rapid response time, short cycle times, at highest transmission rates, and extremely low latency. EtherCAT is a real-time Ethernet field bus. It provides deterministic and accurate synchronized data transmission which classic field bus systems cannot realize. So EtherCAT is optimized for precision machine control. Its high data load and efficient data transmission reduces the data traffic on the network and prevents data collision and ensures short cycle time. It is a flexible network which supports all types of topologies. This is a cost-efficient network with low cost of implementation. EtherCAT is developed as an open standard. The protocol is now supported by dozens of vendors of server drives, remote I/O blocks, actuation, and sensing devices. What is EtherCAT? Why is EtherCAT so fast? What mechanism does EtherCAT use to achieve such a high communication speed? EtherCAT utilizes a processing on the fly approach for transporting data packages throughout each slave in the network. The main feature of this mechanism is data exchange between the EtherCAT telegram and slave is completely done in hardware. So data extraction and insertion between frame and slave is done purely by hardware only. Another feature is data exchange takes place at full frame speed. Processed data is extracted and inserted into the frame while the frame passes through the slave at full speed. The data exchange between slave and frame is completed before the frame moves to the next slave. Another feature of this mechanism is that the slave does not read the entire EtherCAT frame, but only part of the frame assigned to it during the configuration process. The unique features of the processing on the fly mechanism makes EtherCAT communication so fast. EtherCAT is optimized for reduced data traffic. Traditional EtherCAT network consists of a master controller along with multiple slave devices connected to the master using an Ethernet cable. Typically, only one EtherCAT frame per cycle is needed to exchange data with all the slaves in the entire network. Each cycle, a single telegram is passed by the EtherCAT master with the data of all nodes. The telegram is passed around a ring where each node exchanges data with the telegram and returns back to the master with the last slave receives the telegram, which means in each cycle with just one frame, each slave is updated with new output data from the master and the master receives new input data from all slaves. So the low data traffic enables extreme short cycle time for the EtherCAT network. In addition, cycle time is fixed. How many slaves are on the network. EtherCAT slave uses the distributed clock mechanism to ensure a deterministic and synchronized behavior of all the slaves in the network. Each slave is equipped with a separate clock, which has a precise synchronized across the EtherCAT network. The distributed clock mechanism ensures that all slaves read input data and writes output data across the slaves synchronously. This ensures that all the input data, such as digital signal, sensor values, and motor position measurement are all captured at the same time. In addition, all the output data, such as actuator value and commanded motor position values, are outputted synchronously. So exact synchronization is particularly important for precise machine control. For example, this is the case for application in which multiple server execute coordinate motion movements. EtherCAT is virtually limitless when it comes to network topology. Line, tree, star, ring topology, and any combination thereof are supported. Advantage of the flexible topology is existing automation machines and equipment can be easily and flexibly extended. In an EtherCAT application, the machine setup determines the network topology and not the other way around. So any topology can be chosen to flexibly adjust the network to meet the machine's application's requirement. Moreover, thousands of devices can be connected to an EtherCAT without the use of external switches, which reduces the cost and avoids restrictions when designing a network. EtherCAT network setup and configuration is simple. EtherCAT devices are easy to configure and put into use. No addressing needed. EtherCAT itself is based on the processing on the fly mechanism and is not based on TCP/IP. Therefore, no need to administer MAC addresses or IP addresses. EtherCAT master can be set to automatically assign each slave with a unique address, which eliminates the need for manual address setting. EtherCAT is a simple and robust network infrastructure. No external switches are required. Uses standard Ethernet components to keep the implementation costs low, supports cable redundancy, and no network tuning required. It's easy to maintain. It's outstanding diagnostic features, simplifies the maintenance and network troubleshooting. In summary, simple configuration, outstanding diagnostic features, and low maintenance effort are all factors that contribute to a low system cost. ICP integrates a unique features such as high transmission rate, real-time behavior, distributed clock mechanism into our programmable automation controller series to provide the customer with a cost-effective, compact, and high-performance EtherCAT automation controller. ICP provides a complete EtherCAT solution. ICP provides a full range of product components for the EtherCAT network from master to slave. Our EtherCAT products are all developed and manufactured in-house. Both hardware, software, including firmware, are all developed in-house. This has mainly two benefits for our customers. First, our strict quality control ensures a consistent high product quality, which provides the customer with a reliable product. And we can flexible and in short period of time adapt our EtherCAT products to an application-specific requirement of a customer. Now to our EtherCAT master solution. ICP has three types of EtherCAT master in its portfolio. EtherCAT master type has an integrated, real-time, high-performance motion engine that can synchronously control multiple server access. The EtherCAT master types are the PC-based motion controller ECAT M801 series, programmable automation controller the EMP9000, and the EMP2000 series is a palm-sized controller, very compact motion controller. All masters are deterministic, fast, precise, and support a cycle time of up to 0.5 milliseconds. All EtherCAT operation modes are supported, such as DC, pre-run, and sync mode. Depending on the controller type, up to 512 nodes are supported, and up to 64 server access can be controlled in the EtherCAT network. ICP masters all support third-party EtherCAT slaves, which makes it very flexible, as an EtherCAT network can be constructed with ICP EtherCAT slaves and is, if necessary, with slaves from other vendors. Many EtherCAT masters on the market only support slaves provided by the same vendor as a master and does not support slaves from other companies. An EtherCAT network constructed by the master from ICP can be flexibly extended with slaves from all vendors. ECAT, this is our ECAT M01, is our ICP-based EtherCAT master solution. It is a PCI card required with a high-speed real-time OS and a real-time EtherCAT master and a powerful multi-axis motion engine. It converts any standard industrial PC with a PCI slot into an EtherCAT master and a real-time motion controller. Its main features is it achieves a fast time of 0.5 milliseconds. It supports up to 500 slaves in an EtherCAT network. It is deterministic and accurate, controls up to 64 actions synchronously. The slaves with CIA402 profiles are automatically detected and configured by the EtherCAT master to simplify the integration. The motion engine generates several types of motion profiles, including point-to-point, linear, and circular interpolation and contouring. The product comes with an extensive software package such as software utility and workbench for configuring and testing and diagnosing the EtherCAT network. All libraries for motion control execution and for direct exchange data with remote sales are available. The libraries can be linked to any standard programming language. Our EMP9000 series is ICP-DA's EtherCAT-based programmable automation controller with main focus on motion control applications. The device comes with a pre-installed Windows IoT operation system. The built-in motion engine, together with the EtherCAT master, are running on a dedicated processor in a real-time environment to achieve a time-deterministic control of the EtherCAT application. The multi-axis motion control kernel controls up to 32 axes. The stepper and server jars, which meets CIA profiles specification, are automatically detected by the motion engine and can be put into operation without tedious configuration. Motion commands for single-axis and multi-axis synchronous coordinated movements like linear and circular and helical interpolation, all part of the library. The EtherCAT master and motion control features of the EMP9000 series are both very similar to the PCI card EtherCAT M801, as I already just introduced, because both are implemented in a similar way. This means the configuration and diagnostic tools are the same, identical libraries, and programming on the EMP9000 is very similar to the standard Windows-based programming. In addition to EtherCAT and motion control support, the EMP9000 series has several features that makes it an ideal partner for the industrial automation application. Its robust design uses a 3U rack mount, metal chassis, its full metal housing reduces noise interferences, they support a fast and large memory and CPU. Its fast CPU or large memory supports a Windows-based application. PC-based Windows application already developed by the customer can be directly installed on the EMP9000. Multiple Windows applications can run at the same time, similar to a PC-based system, HMI, logic, machine control application, an additional vision processing system, data gathering and processing application all run simultaneously on the EMP9000 platform. It is equipped with a variety of communication interfaces, such as serial, Ethernet, and USB ports, which allows the controller not just to access the EtherCAT network, but also other EtherCAT networks, such as Modbus, can open even, or exchange data with the cloud. Its outstanding features is flexibility and expandability. The EMP series are very flexible and can be adapted to your needs. Expansion slots are provided for local IOs and communication interfaces expansion. ICP does provide a wide variety of digital and analog IO plug-in modules for the local expansion slots, as well as communication interfaces such as serial and Ethernet and USB ports. Fast USB 3R plug-in for camera and vision control are available. In addition, the memory can be increased by plugging in a memory card into the CF card slot. In summary, the flexibility and robustness of the EMP9000 together with the time deterministic and high precision of the EtherCAT-based motion engine and Industry 4.0 capabilities such as machine-to-machine communication and Internet of Things makes it an ideal partner for the machine automation industry. The EMP2000 series is a compact PLC with a real-time EtherCAT master and PLC open defined single-axis motion control functions. The EMP2000 is ICP-DA's entry-level motion controller, which controls up to 128 slaves and 16 axes. The integrated motion functions are limited mainly to a single-axis control. It supports server and stepper drives with the CIO profiles, and programming has to be done via ICP-DA's PLC workbench called Win-GRAF. The EMP2000 is an ideal solution for small and medium-sized automation applications in those areas that are limited by space, and for applications which just require simple point-to-point axis movement. The device comes with a built-in web server. EtherCAT network configuration and diagnosis have to be done via a standard web browser. Single-axis motion control, parameter setting, and testing can be done via a web browser. In addition, the motion path, velocity, and other parameters are shown in an XY graph. The table compares the key features of our EtherCAT master types. The EtherCAT M801 and EMP9000 are similar EtherCAT-based motion controller. Commands such as single-axis, circular, and helical interpolation motion commands are supported. Application can be written in any standard programming language. The main difference between both controllers is the EtherCAT M801 runs on Windows and Linux and can control a larger number of axes. In addition, a SoftPLC runtime with an integrated OPC UA server is available for both the EtherCAT M01 and the EMP9000 controllers, which converts the industrial PC or a PLC pack controller into a standard PLC controller. The EMP9 2000 series, on the other hand, is a pure PLC controller, which application program has to be written in one of the PLC-defined languages, and currently it does not support OPC UA server. Only single or multi-axis point-to-point movements are implemented, and all motion libraries are defined according to PLC Open specification. So all our EtherCAT masters allows the integration of third-party EtherCAT slaves. Now to our EtherCAT slave solutions. ICP-DAS provides a wide range of EtherCAT slaves. The product portfolio includes a large variety of digital and analog I/O modules, as well as converters, gateways, motion control modules, etc. An entire EtherCAT network can be constructed just by using ICP-DAS slaves. And ICP-DAS slaves are all passes the EtherCAT conformance test and have been verified for interoperability with third-party EtherCAT masters, such as TwinCAT, Acontis, etc. This means an existing EtherCAT network controlled by a third-party EtherCAT master can be expanded using ICP-DAS slaves. ICP-DAS provides several types of EtherCAT I/O slaves. The ECAT 2000 series, represented in the module with the white housing. This is our standard I/O slave, and it meets the requirement of most EtherCAT application. The EC1 series, our EtherCAT plugin modules. The EC1 modules have to be connected directly into a prefabricated circuit board. The circuit board can be created by the customer themselves, or the customer has to commission an engineering company with the PC board design and production. So the advantage of this series is it simplifies the wiring process. Then the EC2 series, this series is ICP-DAS high-speed slave, support a cycle time of 100 microseconds. It comes with additional features required for some application. For example, screw lockable RJ45 connectors, external rotary switch for slave address setting. In most applications, the slave address is automatically set by the master. Some customers, although, prefer to set the slave address manually to prevent incorrect installation during the EtherCAT wiring work or during the replacement of faulty devices. In addition, FOE support is provided for updating the firmware if required via the master. And our fourth type is the expansion unit, the EP 8000 series. It's basically combines several distributed slave stations into one compact unit to decrease the required cabinet size. The ECAT 2000 series is ICP-DAS standard EtherCAT I/O type, which meets the requirement of most EtherCAT applications and supports a cycle time of up to 0.5 milliseconds. A wide variety of I/O modules with different channel numbers are available. Modules with 4, 8, 6, and 32 channels are provided. ICP-DAS provides up to 30 types of ECAT 2000 I/O slaves, such as digital modules, photo-isolated DI, relay contact, photo-MOS relay, open collector, and analog module for measuring voltage and current and temperature measurement, etc. The ECAT 2000 series offers an extreme wide of I/O spectrum to choose from, which meets the requirement of most EtherCAT-based automation application. The EC1 series is our plug-in solution for the EtherCAT network. The modules are designed to be plugged directly into a prefabricated circuit board or signal distribution board. The customer can develop the signal distribution board themselves, or outsource the development to other companies, or make use of ICP-DAS engineering service to develop and manufacture an application-specific board. ICP-DAS provides the development of signal distribution board as an engineering service, allowing the customer to focus on their core competencies. The plug-in solution replaces the often time-consuming manual wiring processes. The figure on the left shows the conventional point-to-point wiring process needed for connecting remote EtherCAT I/O modules. Each I/O channel, each I/O point has to be wired one by one individually to an external device, such as switch, valve, sensor, or actuator. So external manual wiring of single wires is time-consuming and increases the risk of incorrect wiring. The right figure shows an assembly of the EC1 plug-in module with a customer-specific circuit board. So the electromechanical design allows the direct connection of the plug-in modules to a circuit board. This means the elaborate, extensive manual wiring of single wires, as indicated by the red circle, is replaced by a circuit board with integrated connectors. The circuit board distributed the I/O module signal via the integrated connectors to an external machine module. This solution is an efficient method for serial production with medium and high quantities. The wiring effort is reduced considerably. The risk of incorrect wiring is reduced to a minimum. In addition, it reduces the required cabinet spaces, thus optimizing the machine footprint. This slide shows, again, an assembly of plug-in modules, circuit board with integrated connectors of different types. So all types of connectors interfaces can be used for sending the I/O signals from the plug-in module via the circuit board and pre-assembled cable harness to an external module. So the combination of I/O modules, signal distribution board, pre-assembled cable makes the installation of the automation system very efficient. The EP800 series is our EtherCAT I/O expansion module. The trend in the industry is to increase the compactness of the machine plant and reduce the cabinet size. So the purpose of the EP800 expansion device is to combine several distributed slaves into one compact unit to reduce the required cabinet space. The EP800 is basically a compact multi-station solution. You can choose chassis with 1, 2, 3, 5, 9, up to 11 slots. Slots can be left empty. The empty slots can be used for future machine extension. And the benefits of the EP800 series is plug-in modules can be quickly and easily inserted and removed from the front of the rack. Plug-in modules are easily replaceable. If one plug-in module fails, it can be replaced with this while the system is running. So it supports hot plug. ICP just provides a variety of different plug-in modules for the EP800 series. The product range of the plug-in modules stretches from various DIO modules, analog I/O modules for current, voltage, temperature measurement, up to gateways and more complex modules such as stepper motor controller. Each plug-in module is an independent EtherCAT slave with its own address. The EP800 allows flexible module combination depending on the application's requirement. So all configuration is done via the EtherCAT master. No additional configuration tool is required to configure the plug-in modules. Next to our stepper controller series, EtherCAT stepper controllers solution consists of single-axis and multi-axis stepper drive. The multi-axis controller type simultaneously control up to 4 stepper motors. The main controller features is it is a 2-phase bipolar stepper driver and is designed to open in an open loop. Depending on the controller type, a maximum motor coil current of 3.3 ampere per phase is supported. High microstep solution allows a smooth and precise motor operation. The controller comes with an integrated incremented encoder to determine the real motor position and DI channels for position latch and hardware limit stop switches. All EtherCAT operation modes are supported, which means motion control can be done with the real-time or non-real-time EtherCAT master. Currently, we have got 3 controller types in our portfolio. The supported motor control current depends on the controller type. The ECAT 2094DS is our newest controller type on the market and supports a current of 3.3 ampere, as well as it supports CIA for 2 defined motion profiles. We provide 2 and 3 channel encoder. Multiple counting modes are supported, such as clockwise, counterclockwise, pulse direction, AB phase, etc. Maximum count rate of 4 MHz supported. It has a built-in hardware latch, which can be used for homing and measurement purposes. The ECAT 2092 supports a multitude of position compare functionalities to meet the different requirements in the automation industry. It's got single compare, fixed distance compare. In addition, up to 200 compare positions can be directly stored in the module. EtherCAT gateways allows industrial equipment that does not support the EtherCAT communication protocol to smoothly exchange data with the EtherCAT master. EtherCAT provides ICP-DAS provides EtherCAT gateways for Modbus, RTU, TCP, and CAN Open. The gateway acts either as a slave or as a master in the local network. The gateway allows the connection of just one module, like a Modbus or CAN Open module, or a network of Modbus or CAN Open slaves. ICP-DAS offers junction modules with 1, 2, 4, and 6 port branching. Junction has 3 purposes and is being used to extend an existing network by extending its topology. By using a junction, a topology, all topologies variants can be implemented like line, star, tree, daisy, etc. Its second usage is to avoid the network, to divide the network into smaller segments, to improve the network stability and prevent an entire system breakdown if one of the network system fails. So the top left figure shows an EtherCAT network with line and daisy chain topology. If one of the slaves breaks down, as shown in the picture on the top bottom left, then the EtherCAT master cannot access the slave following the faulty device. This means a total system breakdown. The top right figure shows the same network divided into 3 segments by using a junction. If one of the segments fails, then the slave of the other segments in the network can still be accessed. So the junction basically makes the system more fail-safe. In addition, makes error detection and troubleshooting easier. And third purpose of the junction is cable redundancy. Cable redundancy can be achieved by implementing a ring topology using a junction module. A ring topology basically enables multipath for the data transmission. In case a cable or connection failure, the EtherCAT frame automatically selects one of the alternate ring paths to access the slave in the network. Therefore, cable redundancy allows the network to remain available and avoid downtime in case of a single cable failure in the network. ICP-DAS EtherCAT fiber converter basically converts copper signal into a fiber optical signal. The main application is to bridge larger distances between the slaves. Up to 25 kilometers is possible between slaves. In addition, it reduces the influence of electromagnetic interferences in an EtherCAT network to ensure stable operation in industrial environment with harsh electromagnetic disturbances. So this is the end of the EtherCAT slave series presentation. Again, it is important to note that all our EtherCAT products are developed and manufactured in-house. Both hardware, software are developed in-house. This allows us to flexible and within a short period of time adapt our EtherCAT products to an application-specific need of a customer. Now to the software development kit provided for our EtherCAT master and EtherCAT-based motion controllers. ICP-DAS provides extensive software tools and libraries for its EtherCAT master to assist the system integrator in setting up the EtherCAT network and implementing his application program. Our EtherCAT master workbench is called ECAT Utility. This software contains configuration and diagnostic function to speed up the construction of an EtherCAT network. In addition, this tool can take direct control of each slave and read its input and set its output data. It supports single and multi-axis motion testing. Basic motion functions such as point-to-point motion and interpolation can be directly commanded using this utility. In addition, this utility contains graphs for tracking the path of the motors and for plotting the motor velocity and acceleration values over time. Further libraries for accessing the EtherCAT network and motion controls are provided. The libraries can be integrated into all standard Windows and Linux programming languages. Plenty of demo programs available. and no in-depth EtherCAT knowledge is required by using our libraries. The motion engine integrated into our EtherCAT master automatically detects, configures server stepper drives, which meets the CIA 402 drive profile specification and operates the motor without tedious configuration. The table below lists the server drives that have been successfully tested together with our EtherCAT-based motion engine. All CIA 402 drive profiles are supported. Virtual access functionality are available, which means a server or stepper drive does not need to be online for the motion engine to generate a motion path. Most single and multi-axis motion commands are implemented according to PLC open-defined specification. This slide shows some basic motion control features supported by our controller, such as T and S curve acceleration, contouring, movement, change velocity on the fly and position on the fly, multi-axis, linear, circular, and helical movement, etc. Our EtherCAT programmable automation controller comes in two versions, the Windows-based controller and SoftPLC-based controller. The SoftPLC controller, the PLC application is to be written with ICBTA's PLC integrated development environment called Win-GRAF Workbench, which I will be introducing in the following. Win-GRAF Workbench is a PLC programming software provided by ICBTAS for programming our SoftPLC controller. It is a development environment for designing, programming, configuring, debugging, and maintaining machine applications. The 5 PLC programming languages, such as structured text, function block diagram, letter, etc., are all compliant with the IEC 61131 standard. The Win-GRAF Workbench development environment comes with plenty of tools for editing, configuring, monitoring, and debugging the PLC application program. Included are network configuration tools for setting up the EtherCAT master, the Modbus and server slaves, and for integrating the OPC UA server. As I already mentioned before, our programmable automation controller are all equipped with expansion slots to expand the local IOs. ICBTAS offers a large portfolio of IO plugin modules. The Win-GRAF Workbench provides tools for configuring the local IO plugin modules, which is needed, for example, to set the engineering units for analog modules. The Win-GRAF platform comes with human-machine interface support for designing graphic control interfaces. Currently, 2 HMI versions are available. The eLogger, which is ICBTA's in-house developed HMI software, and Aveva Edge, formerly known as Indosoft. Both PLC and HMI runtime run concurrently, simultaneously on the same PLC platform. Several fieldbus communication protocols are supported by our soft PLCs, such as Modbus, TCP, RTU, ASCII, master and slave, EtherCAT communication for our EtherCAT-based motion controller, and in addition, Win-GRAF has a built-in OPC server that can transmit PLC data to remote OPC clients like HMI and Cloud Server. All 3 EtherCAT-based soft PLC types have an integrated motion controller. The motion control function blocks are implemented according to PLC open specifications. Most PLC open defined single axis and multi-axis function blocks are available. Up to 32 server or stepper axis can be controlled synchronously. All drivers with CIA4 profiles are supported. Now, I often get the question from customers, what is the difference between an ICBTAS PLC and a PLC like Codesys or Trinket? First of all 3 PLCs are software PLC types. Soft PLCs are designed to run on a standard industrial PC with a Windows or Linux OS with real-time OS extension. So traditional PLCs, such as Siemens, Allen Bradley, or Schneider, are hardware-based PLC. They are designed to directly run on a CPU or hard real-time operation system. A hard PLC is a closed system and its functionality cannot be flexibly extended. The advantage of a soft PLC like Win-GRAF over traditional PLC is soft PLC are more flexible for extension. For Industry 4.0, flexibility is a key component. So SoftPLC, such as Win-GRAF, are developed with Industry 4.0 in mind and can be flexibly expanded to support M2M and IoT functionality. In addition, because the runtime runs on the PEC, it does not just run the PC logic, but also various applications in parallel. So, for example, web server, HMI, OPC server all run parallel with the PLC application on the same Windows PC or Linux PC platform. In addition, SoftPLCs uses vendor-independent programming languages. They use a standardized IEC 61131 programming language. SoftPLC are mainly used for decentralized I/O control, like EtherCAT or Profinet, controlling of EtherCAT or Profinet network, while traditional PLCs focuses on centralized I/O control. So the number of I/O points supported by SoftPLCs are almost unlimited, while the number of I/O points of hard PLCs is limited by hardware and local I/O expansion boards. So SoftPLC compared to hard PLCs have an ability to manage and store large amount of data because the PC memory size is considerably larger than that of a hard PLC. Next, I will show some application implemented by our customer using ICP-DAS EtherCAT products. This slide shows a couple of basic machine applications implemented using our EtherCAT products, like component pick and place, high precision, stationary, welding and gluing machines, quality control, monitoring of production system, and simulation system. An application recently implemented by our customer, a manufacturer of coating machines needed to upgrade a vacuum coating machine designed for coating solar photovoltaic panels with special thin films to increase the efficiency of the solar panels and for panel protection. To increase the efficiency of the machine, the customer decided to replace the traditional motion control with EtherCAT server drives to simplify the system, reduce the wiring costs, and increase the speed and accuracy of the coating process. The customer replaced the vacuum pump with a more efficient one to increase the coating quality. The new vacuum pump only communicates via Modbus RTU. Therefore, a gateway is necessary to enable the communication between the EtherCAT master and the vacuum pump. So the customer, after evaluating EtherCAT products from different vendors, the manufacturer opted for the master and the safe products from ICP-DAS. As the entire machine upgrade could be purely done by using ICP-DAS EtherCAT products, such as master, I/O slaves, gateways, etc. Another factor which contributed to the customer's decision was the engineering service provided by ICP-DAS, which increased the implementation speed of the machine upgrade. For example, ICP-DAS provided some customized motion control functions which simplified the integration process. But in general, ICP-DAS is ready to add features and functionality to our products to meet the customer's application-specific needs. Cutting application automation industry has been realized using our controller. For example, high-speed stationary cutting machines that processes the workpiece as it moves along the production line to increase the production output and efficiency. This type of application requires multi-axis coordinated motion control to synchronously move the cutting tool and the workpiece. Pick and place application, a manufacturer of conveyor system in Taiwan developed a mechanical multi-axis gantry pick and place system to transfer heavy workpieces from workstation to workstation with high precision and for a production plant. The gantry axes are mechanically connected, and therefore tight coordination, synchronization between the gantry axes is required to prevent any distortion in the mechanical structure. To the satisfaction of the manufacturer, the pick and place system was implemented with the EtherCAT-based motion controller ECAT M801 from ICP-DAS by using the gantry control function of our motion controller. The position deviation between the gantry axes could be kept within the system limits. Another field of application is the packing industry, for example, automatic wrapping of products while it's moving along the conveyor belt or filling of bottles, etc. Our EtherCAT products are also suitable for controlling multi-axis simulators. A company specializing in the development of simulators created a flight and a vehicle simulator for training students. The flight simulator are being used for preparing future pilots for realistic flight situations, and the driver simulator for training truck drivers in the truck driving school. Both simulators were implemented using a 6-axis hexapod structure. The company uses our PCI card to control the simulator's 6-axis hexapod, its position, tilt, vibration, etc. In addition, uses analog and digital slaves were used from ICP-DAS to measure the input and the of certain simulation-related sensors. Another application is the semiconductor industry. The semiconductor industry plays a major part or role in the Taiwanese industry. Several projects have been in the semiconductor industry have been implemented with our ICP-DAS products. Precision machine control is critical for the IC industry, for example, in preventing IC defects during the production process, as well as maximizing IC processing throughputs. Precision is also required to place electrical components onto circuit boards. A developer of inspection system for IC components uses our EtherCAT solution to build an automated test plant for IC inspection and quality control. The plant consists of mainly 2 parts. The first part is the inspection machine, which transferred finished semiconductor components to the inspection site for electrical and performance testing. And the second part, the automatic sorting machine that removes IC components that failed the inspection test from the production line. The construction of the test facility is quite complex and requires 20 stepper motors to control the entire inspection and sorting process. The customer realized the project by using our real-time EtherCAT PCI master card in a compact industrial PC. The customer uses 5 sets of our 4-axis stepper controller to control 20 axes and precisely control each step in the inspection process. Another project implemented using our products, a well-known hard disk manufacturer is using our encoder slave to monitor the production process and to carry out quality control after each production and assembly step. For example, it's necessary to inspect each flash chip before the machine begins assembling the hard drive. As the assembly process progresses, a number of different steps are required, such as reading and writing stress tests, high temperature operation tests, etc. So our customer uses our compact 3-channel high-speed encoder counter slaves to control the inspection process and uses the encoder multi-position compare function to trigger the test operation. Using the ICP-DAS solution, you can build an entire machine automation and automation plant. ICP-DAS EtherCAT solution provides an efficient and effective way to control and monitor a production process or improve the production process of an existing plant. All EtherCAT products are developed and manufactured in-house. ICP-DAS is therefore able to flexibly implement any application-specific requirement requested by our customer. Thank you for your attention. Please do us a favor and scan the QR code and give us your feedback. We are now coming to the question and answer session and are open for the forum for questions.